I'm Jeff Yarger. I'm a professor of chemistry, biochemistry, and physics at Arizona State University. I wanted to take a few minutes today and show you one of the resources we have on the Tempe campus at Arizona State University in Interdisciplinary Science and Technology Building Number 1, which is right just north of the ASU bookstore on the main campus. And we have DSC, a differential scanning calorimeter, a fairly new one from TA Instruments, a DSC 2500, that has fully automated mode where you can run the instrument remotely. You can load a lot of samples on there and run, up to 50 to 100 different samples, all by putting them on an auto sampler and have it mechanically moving the samples into and out of the calorimeter. So you can literally load it up and run it for weeks and weeks on time. Now, differential scanning calorimetry is one of the most popular types of modern calorimetry used in academics, in industry, pharmaceutical industry, food industry, etc. It really is one of the workhorses of calorimetry and provides probably the best or most used type of calorimetry for any type of thermodynamic measurement of any sample or of any type of material. And so what I have up here today is looking at a direct view of our calorimeter. And so this is using TeamViewer, which is a type of a program to allow remote access into the computer. Nowadays, most modern calorimeters, just like most modern instruments in any type of chemistry or physics instrumentation, more or less is sitting in front of a computer, and the computer is running the instrument nowadays. We're rarely doing things manually. So you can run this instrument just as well remotely as you can sitting in front of the computer directly nowadays with programs like TeamViewer is what we're using. However, in general, these are general VNC virtual network connection type programs similar to remote desktop on PC, etc. So there's usually general ways to be able to remotely either view and or control a computer. This is a Windows system that interfaces to the calorimeter for running the calorimeter, for setting it up, for running it, for changing the samples with the auto sampler, collecting the data, and this same program even analyzes the data. It's called Trios by TA Instruments. You can go to their website and you can download it for free. They provide the software to anyone. So once you have the data, you can download their software to do any type of analysis in it directly. I'm showing you directly a spectrum I recently collected, my initials, and it's T-butanol that's been run here. So you can see this is an upscan starting at a little below 0 degrees Celsius. And you can see the melting transition here, where the onset of this gives the melting point, the area under the curve gives the change in enthalpy upon fusion. So, and then I have then reversed the process, and you can see that liquid sample freeze. And this highlights one of the things, which is you rarely look at DSC upon cooling. You almost always, it's the heating scan, but it shows both of them. And it's because as soon as it starts to freeze, because of the heat being released from that process, from the crystallization process, you can see it actually start warming up the sample and then finally go back. So generally, we only plot these right here. From this thing, you can set up experiments. You can, put things into the queue. You can set up your sample, what place in the auto sampler it is, the sample mass, the pan mass. You can set up all the run conditions, including where it equilibrates, where it's ramping, how long it's staying isothermal. So you can set up all of the thermodynamic conditions and have it run through as many times as you want. Set this up into the queue and start the experiment. It saves your data. You can have it saved locally or to a cloud directly. And then again, you can pull in this data and go into the results section of this and go into analysis and even start looking at peak integration, for example, enthalpies. If it's a glass, you can look at a whole bunch of different analysis to be able to analyze this data and give you direct thermodynamic data out of it. So this is meant to just show you what's available. We're going to be using this in several capacities at ASU and on both online, remote access, etc. And so I'll be providing more documentation on this to provide students and researchers with how to send samples to ASU, to have them run, and or send samples that get put on the autosampler that you can run remotely yourself, along with some future tutorials on exactly how to set up specific types of samples, run them, etc. Thank you.